Alright, so this is question 10 of the Living Set Higher Maths 2023. In this video, I'll be providing solution to that. So the first one is quite easy there. We'll ask to reproduce T4 following the sequence, T1 as you can see, and then T2 and then T3 here. And a triangle whose height is 8 units and the base is 2 units, and rectangles of equal height is to be stuffed in the triangle as it is explained in this question, the question description here, right? So it is said that Tn is made up of n rectangles of equal height. That's an important information. So this is a presentation here. So T4 is going to contain 4 rectangles, since T1 has just 1 rectangle, and then T2 has 2 rectangles in the triangle, and then T3 has 3 rectangles in the triangle. So T4 will definitely have 4 rectangles in the triangle. All right, then the follow-up question part B is asking to show that the total area of all the rectangles in the T3 triangles are all sum up to 32/3. All right, so this is a replication of the triangle and the rectangle stuffed in it. If I drew this to scale, each of these square grid, so you see the base is 2 units long, and it contains 6 of these units of this square grid. So 6 grids make up 2 units. All right, so if we look at it, we all know that the total height of this triangle is 8. So the height of one of these rectangles should be 8 divided by 3, because there are 3 rectangles. So the height is 8/3. So that's what we know, because the area, to get the area of each rectangle, we must multiply the height times the length. And each of these rectangles should have 8/3 as the height. Now, what are the different lengths of this rectangle? So you see, to get the length of this rectangle, for this first one, you see the first rectangle shares the same length. So it is very obvious that the length of this rectangle here, the first one here, or the base one, A3, the last one, the biggest one there, has the same length as the base of the triangle, which is 2. That's what we have here. Or you can simply say it takes all the 6, because there are 6 grids in the 2 units. So it takes all the 6 out of 6 grids. So we can also represent it this way: 6 out of 6 grids times 2 units. Of course, it's 2, the base of the 2. And then you the middle one is going to be, it takes 1, 2, 3, 4 out of 6 units, or out of 6 grids. So 2, the second, the middle rectangle takes 4 grids out of the 6 to make up the height, to make up the length. So it's going to be 4 out of the 6 total grids times the total unit, which is 2. And then the first one, the smallest one, has 2 of these grids out of the 6. Total 6 grids are 6. So the first one takes 2 of the grids, 2 out of the 6 grids times the total unit of the length of the base, which is 2. So this one, 2 out of 3, we can still represent that as 1/3, because 2 out of 3 is 1/3. And here this one becomes 2/3, because 4/6 is 2/3. So that's why we represent this way. That's how we got the values of this one. So to get the total area of all the rectangles in the triangle now will be area 1, area 2 plus area 3, and then we can then replace them, substitute the values that we got there. The first one there, the smallest one there, is 8/3 times 1/3 times 2, which is what we are representing here. This A1 here, and then we go to the second one, which is 8 over 3. I'm at this point here, 8 over 3 into 2/3 times 2, which is what we're representing here. And then the last one here, which is 8 over 3 into 6 over 6, which is 1 times 2. That gives us 8 over 3 times 2, which is what we have here. And then we have 8 over 3. We can factorize out 8 over 3 because each term here has 8 over 3. So this one has 8 over 3, this one has 8 over 3, and this one also has 8 over 3. So we factorize out 8 over 3, and then we're going to have 1/3 times 2 is going to give us 2/3. So we're going to have 2/3 left in the first term here, plus remember we factorize out this 8 over 3 out there. Now we have 2 over 3 times 2 is going to give us 4 over 3 plus our 4 here, and then we have 2 left here. And just to say we have 2 here. Normally is 2 that we have here, so let's do it here. So let's just sum up this one here. Okay, so 2/3 plus 4/3 plus 2 over 1. So the highest common factor there is 3. 3 divided by 3 is 1. 1 times 2 is 2, plus 3 divided by 3 is 1. 1 times 4 is 4, plus 3 divided by 3 divided by 1 is 3, times 3 times 2 is 6. So that gives us we've united all the fraction now. Then we have 2 plus 4 plus, oh, we forgot plus here, 2 plus 4 plus 6 all over 3. So that's what we have in here now. So the next fraction, would therefore, so we sum all this one here, we got 8 over 3 into 2 plus 4 plus 2 plus 6, sorry, all over 3 that's what we got there when adding all the fractions there. So we now have so 2 plus 4 or 6 plus 6 is 12. So we have 8. Take this circle here. Oh, we are multiplying like that. So 8 over 3 into 12 over 3, because 2 plus 4 plus 6 is 12. So this gives us 8 over 3 into 4. That gives us 8 times 4 is 32 over our 3 here. So that's how we were able to prove that this total area, remember this value here is the total area that we've been summing up here. That gives us 32 over 3 as we were asked to prove. Alright, so we're now on the C part, and we're asked to find the total area of the n rectangles in Tn for n in natural numbers. Give your answer in square units in terms of n in its simplest form. So we can borrow information that we have from the previous example solutions that we provided. If we go here, we see that we were able to actually establish a sequence somewhere here at this level here. So let's just take example of the three rectangles. For example, when we got A3, A1 plus A2 plus A3, we got what do we get here? So let me go back up there and borrow from there. 8 over 3. So this way we simplify here. 8 over 3 into 2/3 plus 4/3 plus 2. So and we finally got so this one here boils down to this one here. So we're gonna use this one in place of what we have in the bracket there. So we have 8 over 3 into 2 plus 4 plus 6 over 3. So this gives us is equals to, so A1, A2, A3 gave us 8 over 3, of course, because 3 is the number of the terms that we're adding up. So we got 8 over 3 into 2 plus 4 plus 6. All right, all over 3, all over 3. Okay, so if let's say we have 4 terms, if let's say we're going up to 4 terms, that will be A1 plus A2 plus A3 plus A4. That will boil down to, because 8 is constant, 8 is the height of a triangle, it doesn't change. So it's going to be 8 over 3, 8, not 3 this time, 8 over 4 into 2 plus 4 plus 6 plus 8 over 4. That's how we get the sum of all the rectangles in T4. To get T5, we do the same. It's going to be 8 over 5 into 2 plus 4 plus 6 plus 8 plus 10 over 5. Now we see now that we're beginning to have a sequence at the top here. We're beginning to have a sequence at the top here. So, but let's say this for 4 rectangles in the triangle. So to go to n rectangles therefore will be 8 over n being the number of rectangles, into 2 plus 4 plus 6 plus 8 plus up to whatever n. So we're seeing a sequence here which is being added. So when the term is 1 at this point, so let's go here. This like it first terms, this first term, let me change ink. All right, so let's change the ink here. All right, let's take black here. So this is term 1, term 2, term 3, term 4. What am I saying? No, this term 3 and term 4. So we see that at each term the term means n is 1. In this case here, n is 1. To get the value of at that n there, we just multiply n by 2. So 2n, which is 2 times 1 is 2. When n is equal to 2, we just multiply by n, because n at that point there is by the term of the n there is 2. And term 3 here, this is the third term here, we multiply by 2. This is the fourth term here. To get 8, we multiply by 2. We multiply the fourth term by 2 to get 8. So if the sequence which is formed now is in terms of 2n, for example, this goes up to get the last value there of the n term is 2n all over n. Same thing here. So if we're supposed to continue, it will keep adding, because if we keep adding that, the next one will be definitely be 5, which will be the fifth term, because this is the first, second, third, fourth. The fifth one will be n. The fifth term there will be n there is n, it is 5, and then we multiply 5 by 2, which is going to give us the 10, and we continue. The next one after the 10 there will be sixth term, and then we multiply by 2, is going to give us 12, something like that. So that's the sequence, that's the pattern that we've discovered. So this is how it comes out like this now. Okay, 2 plus 4 plus 6 plus 8 up to 2 to the power n, 2 times n all over n. Everything over n. Okay, all right, so let me go back to red ink. Okay, so and then we can also now say that here now that this is the same as 8. So 8 into the n times n, because these two are denominators, and operators here is multiplication. So the denominators multiply each other, and the denominators multiply each other. So we're going to have 8 over n squared into 2 plus 4 plus 6 plus 8 plus up to 2n. So remember the denominator n here is here. It's already here now. So what do we have here is, we can now see now that we have a sequence here with a difference of 2. This forms a sequence, an arithmetic sequence with a difference of 2. So each term is different from the next term. The next term is different from the previous term by a value of 2. So as you can see here, 40 with 2 is 2, 60 with 2 is 2, 80 with 2 is 2, and so on. So it's an arithmetic sequence. So how do we are supposed to sum up all this up to the n term, which will be the value of 2n. We don't know n. So we are supposed to sum that up. And how do we sum up the first n term in an arithmetic sequence? So if we go back to our formulas, I have to take that over there. Let's copy. I don't know where I was now. All right, I'm here. All right, so I have to paste it somewhere here. Let's see. Okay, this is my formula here. So we can see, so this is the formula to find the sum of the first n terms in an arithmetic sequence. And we have our arithmetic sequence in here. So how do we find the total sum? Because obviously we don't know the terms in between 8 up to 2n, which is the n term. All right, so to get that sequence, we need to use this formula now to get what is inside this bracket. So we can now multiply by the 8 over n squared. So let's keep this one for a while. We're going to come back to that, and then let's sort out the this area here. Try to sort that one out. So we're going to substitute now. We know our a here is 2. This is our here. Let me change this ink here. In this formula, our a is 2. Our n is n, we don't know n, and then our d is 2. We just discovered that the difference in this arithmetic sequence is 2. So we know our a is 2. A is equals to 2. And d is equals to 2. D, which is our difference. All right, so what do we have now? We need to substitute now. So the formula now is, let's go down. Of course, this is taking space because in the explanation. If we're just solving it, then you just make sure you just follow the necessary lines without a lot of dirty work that I'm doing now. But this just so we understand, be on the same page, and then we go through. So the sum will be, let's substitute our a is n over 2 into 2 times a. Our a is 2, as you can see here, and then this plus here, plus, and then this d, n minus 1, and our d is 2. That's what we have there. Remember, we're solving just this one here. We are trying to solve this one here, and when we get the value here, we multiply by this one here. We don't forget this. All right, so this is gonna give us, of course, we can always put this one at the back so we don't forget to bring it down. It's very important and necessary to do it that way. So we're gonna have, let's keep doing 8 over 3 here, 8 over n squared. So we don't forget to keep bringing it back. We don't need to go back up there. Okay. All right, we go back down there, and then so we have what do we have? So we expand. So we have n over 2 into 4 plus 2n minus 2, 2n minus 2. All right, 8 over n squared And then here we go, keep going, make sure we don't lose our track. So this is going to give us the next level. There is n over 2 into what we have here now is 2n minus 2, yeah, 2n plus 2, sorry, because 4 minus 2 is going to be 2, so we have 2n plus 2, right? 2n plus 2, which is left here, into what did I write here? This n over 2. Okay, yeah, this n over 2. And then we have our 8 over n squared. 8 over n squared here. Okay, we keep going down. This is equal to now we can factorize out 2 out there as well. So we're gonna have, if we factorize out 2, we're gonna have n over 2 dot 2 into n plus 1, 8 over n squared. Okay, this gives me, these 2 will cancel this ink, these 2, and then we're going to have n into n plus 1 and 8 over n squared. So we see now that change again. So because we're going to have we multiply these outside ones, leave the brackets intact first. So we're going to have 8n over n squared into n plus 1. All right, then we're going to have, so of course 1n will cancel 1n there, so this n will cancel 1 here, and then we're going to be left with 8 over n, all right, into n plus 1. Yeah, that's what we have. And when we expand this, we're going to have 8 over n times n is going to be 8n over n. 8 over n times 1, 8 over n. So this one will cancel this one here, and then we are just left with 8 plus 8 over n. So this is our simplified format of what we're supposed to give a solution. Okay, so now we have the D part of question 10. The total area of the rectangles in the nth term of a different sequence groups of rectangles is as follows for natural numbers. Okay, the total area an is given by 8 into n minus 1 over n. Of course, we have the structure there. Now work out the first value of n for which the area an is greater than 95% of the area of the triangle on the right. Okay, so what we have going on here is let's first calculate the area of this triangle. Remember, we have to find a value for which the area of this new sequence, the area of the total rectangles in this new sequence must be greater than the area of the triangle. So we need to find the area of this triangle. So the area of a triangle is given by half base times height. So if we get, we know the base of this triangle, base B is equals to 2 units, and the height, this B, and the height is equals to 8. So the area of triangle, is equals to half times 2, which is the base, times height. That gives us these 2 cancel 2 here, so that gives us 8 as well, 8 unit. So what we've been told is that the area an, which is given by 8 into n minus 1 over n and it's in the bracket there, must be greater than 8, 95% of 8. So it should be greater than, of course, this is greater than sign. 95% is the same as 0.95. That is 95% is 95 over 100. That's how we got 0.95. All right. So 0.95 of 8, because the area of triangle is 8. 95% of 8, which is 95 times 8. Okay, which is, we can just write it like that. All right. So we're definitely going to have now, of course, this is the operator sign here. So this 8 will cancel this. If we divide both sides by 8, it will cancel 8. It will cancel 8. And then we'll be left with n minus 1 over n is greater than 0.95. Okay, which we can also extend this to n minus 1 is greater than here, so we can extend this to n minus 1 is greater than 0.95 n. Okay, we are multiplying this n. So if we multiply both sides by n, this n will go away, and then we multiply 0.95 by n. So that's what we have there. So so we get n. So we have n minus 0.95. So we're bringing like terms together now. 0.95 n must be greater than 1. So we take 1 to the other side. So what do we have here? What is 0.95 n minus 0.95 n? I'm going to have 0.05. Sorry, that was a mistake there. Okay, so because 1.00 minus 0.95, so it's going to give me, put 1 over there, put it becomes 5. 9 take away 9 is 0, and then our decimal point here. So that's how we get. So so 5 0.0, so 0.05, not 0.5. So 0.05 n is greater than 1. So n will be greater than 1 over 0.05, which just gives us so this is just gonna be like n is greater than 1.00. So we add zeros to, no, sorry, not the 0, we add zeros 2 decimal places because of these two. We move 2 decimal because of these 2 decimal places. So to equate that, divided by 5 now. Okay, so it'll be 100 divided by 5, which is going to give us 20. All right, so n is equals to, n is greater than 20. So if n is greater than 20, n should be greater than 20 for that condition to be met. So if n is greater than 20, the next value would be, because it's a natural number, so the next value after 20 will be 21. So n must be equals to 21, because here we say n is greater than 20. All right, so n must be equals to 21 to get the value. Okay. Okay, so now we have question 10 of the living set, paper 1, higher level paper 1. E, the first part of E, the area of the shaded square in diagram B is that. It's given to us. The volume of the pyramid is that. Yeah. use the integration to find the volume of the pyramid in cubic units in terms of C and H. Okay, so I'm gonna give some explanatory statements here for understanding purposes. All right, so we're given the area of a square at a distance x from the apex, that's from the tip of the pyramid there. Okay, and so now from the apex of the pyramid, which is represented by the function, okay, we got the function there. This is our function here. So we're gonna have that function there, yeah. Okay. Now, so we're now asked to, the task we have to perform here is to integrate this function, all right, where x is equals to 0 up to where x is equals to h, all right, and then to find the volume of the pyramid, right? So ground rules. So what we know, okay, so what we do now, we just say we can just say here v, oh nope, make it thinner there. Okay, so because v is equals to differentiation, the integral of when x equals to, from h to, when is x equals to 0 to h. Okay, then s, this is our function of x. Okay, dx, just copying down what we've been given there, which is equals to in the place of s of x, now we'll replace with this one here. So this is equal to the integral of h to 0 to h. Okay, and then we're substituting the s of x there, which is x squared c squared over, what's that, h squared, or h squared. Clean up this there. All right, so I'm just copying that down. All right, so next thing now, that's our integration. Okay, they're integrating the area function, so we just integrated the area function here. Now the next thing we need to do now, we need to calculate now the antiderivative. The antiderivative now is, so if we look at it, we need to express, if you look at here, this x squared in terms, or the antiderivative of x squared, in the antiderivative of x squared with respect to x is given as follows. So this would be, let's take this one out first. Let's take this one out first. Yeah, this one, this x squared. So if we take that x squared, so x squared, the antiderivative of x squared with respect to x is given as, well, I had x squared with respect to x is equals to x cubed over 3. It is given by x cubed over 3. Yeah, x cubed over 3. So we now need to use this now to substitute in there. So we're going to have, go back to my block there. So in the place of x squared, we're going to substitute that with this one. So we're going to have we're going to have here, in the place of x squared, we have x cubed. So I'm working with this one now. X cubed over 3. That's x squared. We're replacing x squared there, times let's just use dot there so we don't get a lot of x's there confusing. C squared over h. That's what we have. Okay, c squared over h, and then on. So Now we need to apply now the limits of the integration. So when we evaluate now the antiderivative from x is equal to 0 to x is equal to h, and this is going to give us v is equals to, that's the volume, is equals to, let's say, let's take this one first, c squared over h. That h is squared, so I forgot this h here, squared. Is it? Was it? Yeah, it's squared. It's squared. Yes, as a h squared dot. Okay. What we have here is, so when we're using h here in the place of c, in place of x here. So instead of x here, we say h cube over 3 from 0 to h. Okay, so see, this simple substitution gives us this one, which is the same as c squared over h squared dot, we're evaluating this one now, h3 over 3 h3 over 3 minus 0. Okay, so that's our volume there. But then so if we simplify this, now we're going to have v is equals to, let me write it out there, v is equals to c squared over h squared, c squared over h squared dot h cube over 3 okay, c squared over h squared dot h cube over 3. No, we're here, c squared over, yeah, h cube over 2 because minus 0, well, minus 0 is still the same thing there. So that's going to give us, so we have h cube at the top, we have h squared at the bottom there. So these two of these will cancel 2 here, and we're going to be left with 1 h there. So if we do cancellation here, so we're going to cancel, this one's going to cancel, and then this one's going to cancel here. We're going to be left only with 1 here, h1, h to the power 1. So this is going to give us c squared dot h over 3. Yep. So this is the solution that we're supposed to provide, the final solution. That's it there. Okay, so this is part C, E2, sub 2. But before I continue to provide a solution for this one, I just want to emphasize a point here, should in case it is not understood how this became this here, the antiderivative of x squared, the x squared we have here. Remember that if you have x squared like this, the derivative, let's say, no, let's take this one here. X, we said x, the derivative of x cubed over 3. If I ask to get the derivative of x cubed over 3, obviously the formula is the power. You multiply the power, it becomes, the power there is 3. So 3 times 3 dot x to the power n minus 1, which is 3 minus 1, which is 2. Of course, then you bring out this 3. So you have 3 divided 3 here. There you got x squared. So you're left with x squared. So antiderivative is that to get x squared, if you do the antiderivative of x, so what number that was originally there before they got to x squared. So you're anti-engineering, reverse engineering. All right, so that's how we got the antiderivative of x squared is x cubed over 3, because if you're looking for the derivative of x cubed over 3, the derivative of x cubed over 3 is going to be x squared. So it's reverse engineering. All right, so that's how we got x cubed over 3, because it is the reverse engineering of x squared. What is the number that gave the derivative to x squared? What number that was there that could give x squared as a derivative? It is x cubed over 3, because x cubed over 3, the derivative of x cubed over 3 is x squared, which means 3 times x to the power 2 over 3, it gives you x squared. All right, so that's this point that I wanted to clear out before we go to the next one. Okay, so we go to the next question now. Okay, so this one now, x starts to increase at a rate of 3 units per second. This causes x to increase as well. Find the rate of change of x squared f of x, s of x with respect to time at the instant when x is half the perpendicular height of the pyramid. Give your answer in square units per second in terms of C and H. All right, so to solve this now, this part of the question now, what is this? So let's just state that what we have, there's a question here. Let me go back to my board here. So what we actually have here is we're given x, s of x, s of x excuse me, is equal to x squared dot c squared times c squared all over h squared. That's what we've been given. Okay, because the area square of the distance x from the apex of the inside of the pyramid. Okay, and we know that when x increases at the rate of 3 units per second, okay, that's what we've been given to say. X increases at the rate of 3 units per second. So the rate of change of x with respect to time, dx over dt, the rate of change of x with respect to time, that's how we denote that, of course, is equals to 3. That's what we've been given as well. Okay, we've been given that one, and then we need to set up these things now, the functions. So now to find out, we need to find out the ds, the rate of change of s with respect to time. That's what we don't have. We've seen the rate of change of x with respect to time. Now we need to find the s over dt. So the rate of change of s with respect to time, and we know s of x, which is x squared dot c squared over h of x, or over h squared. Okay, so to find out ds over dt, we first need to find the ds over dx. When we get the ds over dx, then we get a differentiation. And then we'll be able to differentiate using the power rule. And then when we get the power rule, then we can then chain it together using the chain rule. Okay, first we use the power rule, then we use the chain rule. Okay, we're gonna have ds over dx ds over dx, the rate of change of x with respect to x, all right, is given by d over dx. So ds, we know ds over dx, which is get our s here, x squared dot c squared over h So the x squared dot c squared over h squared, x squared, yeah. So that's our ds over dx there. So now we need to calculate. So we now need to calculate the s over the x. So the s over the s, to calculate that. So we need to get the differentiating. So let's differentiate this one in bracket. When we apply by the coefficient. So remember the differentiation. If we get the differentiation, this one will become oh my gosh, this become 2 dot the coefficient, the exponent of x here is 2, the index of x there is 2. So we remember the rule of differentiation rule. We get 2 into 2 dot x to the power 1. Okay, so 2 minus 1, x to the power 1 dot c squared over h squared over h squared. Okay, we got that like that. Okay, so 2 dot, yeah, that's what we got there. Then we now evaluate the ds over dx. So if we get the because we're told, if we go back to the question again, find the rate of change of x or of s of x with respect to time at the instant when x is half the perpendicular distance. So half the height, okay, perpendicular height of the pyramid. So what is the rate of change when it is h over 2 high, that is half the height? Okay, so let's find now the rate of change at this point where the x is half the height of the pyramid. So so let's look for the x over the x. We'll look for the x, the s over the x, where at the point where x is equals to half h over 2, the perpendicular distance. This is going to give us this our 2. So we are just merely substituting, because at this point h is equal to h over 2. So in place of x, we substitute h over 2. So this over 2, let me just go over there. This is going to give us this over 2 dot h over 2 dot c squared all over h squared. Okay, what is this? All over h squared. So we evaluate. So if we apply chain rule now, so chain rule which says that because if we apply, we're now trying to get the ds, because this is the s over dx, the rate of change of s with respect to x. Now to get the rate of change of s with respect to t, so we're now looking for d of s with respect to t time. This is given by, we use the chain rule now, which is going to be the d of x, the d of s over d of x. So it's going to give us the d of s over d of x, the rate of change of s with respect to x, dot times the rate of change of these times. Times the rate of change of x with respect to time. Okay, the rate of change of x with respect to time. Now we have here, this is going to give us d of s. This is going to give us d of s over d of x. We have here, we already evaluated that up here, which is 2 into, it's going to give us, so we are just substituting this one because d of s over x, this is what we have here. So we need to substitute this one in here. So we're going to have 2 dot h over 2 dot c squared all over h of x h squared. So this is this one here, then this dot here, this times here, then dx over dt. But we know dx over dt at this point, we're told that the rate of change there is 3 seconds, units per second. So dx over dt, the rate of change of x with respect to time here is 3. So the value of this dx over dt is 3. Okay, so we now have evaluate more. Let's deal with the numerator. Okay, deal with the numerator first. If we deal with the numerator, we see that we're gonna this 2 is gonna cancel. So this is like, let's deal with the numerator. Forget about h over h at the bottom there. So just do just with this part first. So we're gonna have 2 dot h over 2. So this 2 will cancel this 2 here. 2 dot h over 2 dot c. That's gonna give me h. That's c squared. That's gonna give me yeah, because now 2 will cancel 2, so it's gonna give me h hc squared times this 3 over h squared. So I finally get, well, we can still cancel 1 h here, and h here goes away. So we're going to finally get 3.3c squared over h, because 1 h is left here. 1 cancel 1 here to h, and h squared 1 here to. The final answer is 3c squared over h. 3c squared over h.